Hello everyone, welcome to my talk, CertifiedDCOM, the Privileged Escalation Journey to Domain Admin. Today I will uncover a new remote attack service of DCOM and DCS, and show you how to abuse it to get domain admin privileges. First, let me introduce myself. I'm Tianzi Ding, I'm from Tencent Security Xuanwu Lab. My research is mainly about Active Directory security, cloud security, and web security. Here is the agenda. Firstly, I will introduce some basic knowledge and previous research. Then I will walk through how to discover the remote attack service and how to exploit it. And finally, show you the patch and mitigations. So what is COM? In short, COM is something like a binary library. It provides methods that can be called by the client. The COM server can be a DEL or ESE with COM classes in it. A COM object is an instance of a COM class, which possesses one or more interfaces. The interface contains methods that can be called by the client. The COM server can be in-process, out-of-process, and even a remote process on a different machine. In-process server means COM objects are running in the same process as the client. Out-of-process means the COM objects runs in a different process. A COM server can even run a remote machine, which is also known as DCOM. Invoking interface methods or in-process COM objects are processed as ordinary function calls. Cross-process COM calls are handled by ARPC. And DCOM communication between different machines are made through RPC over TCP/IP. In the out-of-process COM, when a client requests a COM object, it will communicate with the RPC as a service first. The RPC as will check if the COM server is running. If not, it will start the COM server and create a new COM object in it. The process is called launch and activation. After the COM object is activated, the client can interact with the COM object through ARPC. The workflow of the DCOM is similar to the out-of-process COM, except that the client and server are on different machines. The client needs to communicate with the local RPCSS first. The local RPCSS then processes the request for the COM object to the RPCSS on the remote machine. The communication protocol between the two machines is RPC over TCP/IP. In recent years, potato attacks and Kerberos Relay are well-known research on Windows COM. The history of these attacks can be traced back to James Foshall's MS 15067 8 years ago. It's the first vulnerability to abuse DCOM activation using cold-get instance from iStorage API. All of the following potato attacks and Kerberos Relay abuse the same API. It's indeed a very powerful attack vector. But all this research is about the local attack surface. None of them talked about the DCOM remote attack surface. Local privilege escalation is critical. I think people still prefer remote attacks. So where's the forgotten remote attack surface? Let's first look at how cold-get instance from iStorage works. Cold-get instance from iStorage is an API for creating COM objects. The difference between this API and other COM creation APIs is that it receives an iStorage interface pointer parameter and initializes the COM object from the storage object. An interface pointer is actually a memory address. The interface pointer cannot be passed directly between the client and the server in cross-process communication because the memory of the client process and the server process are not shared. As a solution, interface pointer will be marshaled into a data structure named OBJIF custom. And the class ID and the data of the OBJIF custom can be customized by the client with the get unmarshaled class method and the marshal interface method. On the COM server side, it will unmarshal the OBJIF custom sent by the client to get the COM object and the interface pointer. A COM client can set the class ID of the marshaled data shared class to the class ID or point moniker and set the data to an OBJF standard. When the COM server AMA shares the OBJF custom sent by the client, it will create a point moniker object and call the AMA shell interface method to AMA shell the OBJF standard. There are two important fields in OBJF standard, which is called the stream binding and security binding. The stream binding contains a network address, shows where to find the object. When the COM server AMA shell the OBJF standard, it will call resolve OSID2 to resolve the object explorer ID, and the RPC will initiate an RPC connection to the address specified in the stream binding. The resolve OSID2 can connect to a local or a remote server. This depends on the stream binding. The return value of the OSID2 is OSID bindings. Which is also consists of stream bindings and security bindings. The COM server will then initiate a DCOM connection based on the stream bindings and the security bindings specified in the OSID bindings. In previous research, the attacker's COM client and the victim's COM server are both local processes. The server uses code get instance from my storage to trigger the high-privileged COM server to authenticate to the attacker's rogue server. The attacker can then impersonate or relay the authentication for local privilege escalation. We know that DCOM allows us to active COM object remotely. Thus, code get instance from iStorage store remote COM activation with DCOM. When we looked into the definition of code get instance from iStorage API, we can see that it allows users to set the class contents to class contains the remote server to active COM objects on a remote machine. And the code server infrastructure allows users to set the remote computer name, the authentication information used in the DCOM communication. Also, seems this API also supports remote COM activation. So can we call us a remote computer connected to us and then perform NTM or Kerberos Relay attacks? Suppose we have compromised a normal domain account. We can authenticate to any domain computer. But when we try to use code get instance from iStorage to active a COM object on a remote domain computer, we got access denied error. That's because the default COM security restrictions in Windows. There are two paths of ACLs here, the system-wide ACL and the process-wide ACL. These ACLs define restrictions on COM launch, activation, and access. When a COM client launch or activate or access their COM object, the client needs to pass the system-wide ACL first, and then pass the process-wide ACL. In the default system-wide ACL settings, only users in specified high-privileged local groups, like local administrators group, distributed COM users group, are allowed to perform remote launch and remote activation. Therefore, by default, a normal domain account cannot launch and activate any COM object on a remote machine. I believe this is why so little research has focused on the DCOM remote attack surface. So how to use domain user privileges to launch remote attacks? Where is the remote attack surface? To perform remote attacks, we need to break the default COM system-wide restrictions first. Let's think outside the box. Although Windows has strict COM restrictions by default, there are many services in Active Directory that also provide COM access. This service also expands the attack surface. So next, we extend the attack service to Active Directory and try to find services that have customized COM security configuration other than the Windows default configuration. The remote desktop service modify the Windows default COM security configuration. It allows some RDS groups to perform remote launch and remote activation. But in the RDS default configuration, no low privileged domain accounts in these groups. The SCCM also modifies the Windows default COM security configuration in order to provide remote WMI access to SMS admins. But by default, there's also no low privileged domain accounts in SMS admins group. Finally, ADCS comes to rescue. If ADCS is installed on a machine, the local certificate service DCOM access group will be granted a remote activation privilege. The authenticated users in the certificate service DCOM access group by default, which means any low privileged domain accounts have remote activation privilege on ADCS. Why is there such a special configuration on ADCS? That's because ADCS needs to provide certificate signing request sent by the client. In Active Directory, all domain users and domain computers are allowed to send certificate signing request to generate validate certificates. ADCS implements MSWCCE, which is a DCOM protocol to support the certificate signing. And it grants all authenticated users privileges to active the COM object introduced by MSWCCE. Now we can pass ADCS system-wide ACLs check. Next, we need to find out which COM classes can be exploited for further attacks. As we mentioned before, in addition to system-wide ACL, we also need to consider some process-wide configurations. The configurations contains process-wide ACL, identity, authentication level, impersonation level, and others. These settings are defined in the registry by default and can also be overwritten by the initial security API. The process-wide ACL defines who can launch, activate, and access a COM object remotely. As an exploitable COM, the process-wide ACL needs to allow remote activation by low-privileged domain accounts. And the COM server must be already launched in ADCS because certificate service DCOM access group doesn't have remote launch privilege on ADCS. The identity defines the user identity the COM server runs as. It can be an interactive user, a system account, or other specified users. The COM server will use this identity for network authentication. For an exploitable COM server, its identity can be set to any user except the local service, because the local service uses anonymous user for network authentication that has no exploitable value. The default value of COM authentication level is RPC auth level connect, which means signing and sorting are not required in DCOM connections. That's very helpful for relay attacks. The impersonation level determines whether the identity of the client can be impersonated by the server. Some services like RAS and SMB need to impersonate the client. These services require the client's impersonation level to be set to RPC imp level impersonate. After reviewing all COM classes on ADCS, we found these exploitable classes: cert service request, cert service admin, other COM classes used by MSWCCE. They are installed in ADCS by default. OSCP request and OSCP admin are classes introduced by the ADCS online responder role, which is not a default role of ADCS. You need to install it manually. All this exploitable COM class has identity to set to system, which means the COM server will use the ADCS machine account for network authentication. The authentication level and the impersonation level settings shows that we can relay the ADCS authentication to LDAP service. So if the attacker has compromised a domain account, he can use coget instance from iStorage to activate an explorable COM object on ADCS remotely. When ADCS connects back to the attacker returns a forged OSRD binding to the ADCS and sets the stream binding to require NTLM or Kerberos authentication. ADCS will use the specified authentication method and ADCS machine account to authenticate to the attacker. The authentication in this DCOM connection will adhere to the process-wide security configuration of the explorable COM. The authentication level will be connect, and the impersonation level will be identity. So attacker can then relay the NTLM or Kerberos authentication to LDAP and perform resource-based delegation attack or shadow credentials attack with the ADCS machine account. Here's the complete overview of this attack. The final step is to escalate privileges to domain admin. It's easy to get domain privileges after resource-based delegation attack or shadow credentials attack. I gave two attack passes here. You can RCE on ADCS and escalate to domain admin with the golden certificate attack, or you can request a domain admin certificate first and then use the certificate to request a domain admin service ticket, domain admin's TGT with PKI ID. Finally, you go to the domain admin, and you can take over the entire Active Directory and RCE on any domain computers. Let me show you the demo of the second attack pass. The attacker is a user in domain users group. Next, let's run the CertifiedDCOM exploit and execute command with WMI on the domain controller. Okay, let's run the exploit. Now you can see we can execute commands as domain admin on domain controllers. Oh, thank you. The patch for this vulnerability was released on October 2022. The patch killed the DCOM to LDAP relay with ADCS. It raised the authentication level to packet privacy in the certificate service. And a month later, DCOM authentication hardening or released. It automatically raised the authentication level for all non-anonymous activation requests to packet integrate. This hardening also kills this vulnerability and can defend against most DCOM relay attacks. Enable LDAP signing and channel binding can also protect you from this attack. We just talked about relay to LDAP. How about other services? We didn't find a COM class that supports DCOM authentication with impersonation level set to impersonate. So we can't relay DCOM to other services. But how about the resolve of OSRD2 RPC? There are also authentication messages in this RPC connection. The impersonation level of the resolve OSRD2 RPC connection is RPC input level impersonate. So we can perform NTL relay to the ADCS HTTP endpoints and MSICPR. But this requires two ADCS servers in a domain because we can't relay NTL back to the same machine. How about Kerberos Relay? Can we set arbitrary SPN in the security binding to make a resolve OSID2 RPC authenticate with any service per simple name? Actually, we can't because the machine name of the SPN in the resolve OSID2 RPC authentication is forced to the machine name in the stream binding, so we can't trigger Kerberos Relay with security binding. How about other RPC protocol sequence? We can also control the tower ID of the stream binding. The tower ID determines the RPC sequence type. RPC supports many transport sequence type with different high-level protocols like TCP, UDP, SMB, HTTP, etc. Can we abuse these protocols for NTRM or Kerberos Relay? After I checked all this RPC protocol sequence, I found the Resolve OSID2 RPC supports NCNCN IPTCP and NCNCN HTTP. The DCOM connection supports one more type, NCNCN NP. NCNCN IPTCP is what we talked about before. How about others? The NCNCN HTTP is also called RPC over HTTP. The RPC client will use RPC over HTTP version 2 first. If version 2 failed, the client will fall back to the version 1. When using RPC over HTTP version 1, the client will establish an HTTP connection with RPC server and send a HTTP request using RPC connect as the HTTP request method. This is a persistent HTTP connection. The raw RPC package will be sent in the same connection. One thing to notice is that there's no authentication in HTTP layer. The authentication is only in the RPC package. RPC over HTTP version 2 is a bit more complex than version 1. But the same as version 1, there's no authentication in HTTP layer. The authentication is only in the RPC package. So as for NCNCN HTTP, we can relay NTRM. We can perform NTRM relay, Kerberos Relay, 2L depth with RPC packets in the HTTP connections, the same as RPC packet over NCNCN IPTCP. In comparison to NCNCN IPTCP, RPC over HTTP has the potential to bypass some network restrictions or NDR devices in some situation. The DCOM connection also supports RPC over named pipe. The RPC over named pipe uses SMB protocol as the transport protocol, and it uses the machine accounts for authentication in the SMB layer. The impersonation level of the authentication is security impersonation, which means the server can impersonate the client. So we can perform NTRM relay to the HTTP endpoints or MS RCPR in another ADCS server, but they still need 2 ADCS servers. And the Kerberos Relay still won't work in RPC over named pipe. When I take a closer look at the patch for the vulnerability we discussed before, I found something interesting. The patch introduced a new function named initialized COM security in the search service. The new function evoked the initialized security to configure the process-wide COM security. It changed the authentication level of the search service to packet privacy to patch the vulnerability. And the impersonation level is also be changed to the RPC imp level impersonate. The impersonation level is exactly we want. So now we have DCOM authentication with impersonate. With this patch, we can relay DCOM to ADCS, HTTP, or MS RCPR running on a different machine. But for Kerberos Relay, there's no restrictions for Kerberos authenticating to the same machine, so we can perform Kerberos reflection, relay Kerberos authentication back to the same ADCS server. Here's how the attack works. We can use both NCNCN IPTCP, NCNCN HTTP as RPC sequence here, and we can relay the authentication from the ADCS back to itself. Kerberos reflection is not a new vulnerability, but a new exploit technique. To mitigate this attack, just enable EPA on your ADCS HTTP endpoints, EPA can protect you from both NTRM relay and Kerberos relay, and just keep the default settings of the MS SPR to defend this attack. Okay, in this talk, we introduced a new remote attack service of DCOM and ADCS, and several attacks which can lead to privilege escalation from domain users to domain admin. We also take a Kerberos relay to the next level, make it a real remote attacker vector. One thing to notice is that this research is in the default configuration in Active Directory. If you have some customized DCOM with misconfigurations, like allow any domain user to active your COM object remotely, these attacks may also work. There are some mitigations for you. Update your ADCS to install the patch, update all your machines to enable DCOM authentication hardening, enable protections for relay attacks, such as LDF scanning and channel binding, and the EPA for ADCS HTTP endpoints. And finally, check your customized system-wide and process-wide COM security configuration. My research is based on the remarkable work of these outstanding researchers. I'm just standing on their shoulders. Thanks for their work. Thank you for your time. Hope you enjoy this talk.